So we've got these two. We've just now, here's the thing. We've got another junction. So we should do this again, right, at this point. But here's the thing. This current's going to come down here, right? This current's going to come around. I3 is going to come around here and hit this. These two together then are going to cause something to go that way, right? Which is just I1 again, right? So there's no new information found about at this junction point, right? But what we can say, looking at this, for our first equation, we know that I1 is equal to I2 plus I3. If we had done it for this junction point, we would have gotten the same amount of information, right? We would have just found out again that I1 is equal to I2 plus I3. So don't do it. Save yourself some time. Okay? I wish they gave me more colors to work with. All right, we'll go with that. Cool. So the next thing we want to do is let's go with the loop rule, right? So we need to identify closed loops. How many closed loops do you think we have? 3. We've got 3 loops, all right? We have a loop right here. We have a loop right here, right? And we have a big loop. Okay? So we've got all kinds of loops. And what you're going to want to do is just label them. All right? So this is going to be loop A. This is going to be loop B. And we're going to label this loop C. Okay? So now what we'll do is we're just going to go around the loops and write the equations and what they tell us. Okay? So let's start with loop A. So starting with loop A, they might tell you sometimes in a problem, they might say, all right, going from like junction points like A, B, C, D, A, they'll tell you the path to take. So that's where you would start. We don't really have that, so I like to usually just start at the battery. Okay? So in this case, when we come out, should this be positive or negative? Should be positive, right. So we're going to call it, we're going to say V1. Right? And as we go along, we hit this guy. Right? This should be minus I1 R1. Right? Okay. And then traveling through here, when we come out of this battery source, what should we get? Minus V2, right? Because we're coming out of the minus side of that, right? So it's minus V2, right? If we're following the loop, right, we get that minus. Okay? So then we come down and we hit this resistor. What would you call that? R4, right. I3, R4, right? I didn't write it right. That should be an I3. Okay? And then we come through here, and we get to R2. What would that be? It's I1, remember? Because it comes back. These two loop around and meet here. I2 and 3 come back. It gets back to I1. Okay? And then when we get back here, we're at 0, right? So all that is equal to 0. In this loop, I3 is not in loop A. Okay? So, who cares? Okay? Now, what you could do if you really wanted to get crazy, and you may have to later, right? You could take this information, right, and put it in terms of, your different I's. So wherever you have I1, you could substitute I2 plus I3 to get rid of those I1s, right? You may have to at some point. But honestly, you're not going to need to solve a problem like this on an AP test. They're going to ask you like the tipper's question, like what happens to the battery one when it gets bright, cold, things like cold. dim, things like that. Okay? So now if we go through loop B, let's start again. Plus V1, right? Minus I1 R1. Okay? And as we come down, right, minus I2 R3. And then we come through here, and you get I1 R2, and that's equal to 0. Okay? And that would be it, because we've made the full loop. C is the last one. C is where you're going to see something interesting. Okay? So let's start here, right? And we're going to go around. We picked this to be the direction that we're going to travel in. Okay? I'm going to start at the battery. Okay? Sometimes, usually they would tell you where to start. They give you a path to follow, but because we don't, I always pick the battery because it's a good good marker point. Okay? So in this case, as we leave the battery, following our direction we say to be positive, this would be minus V2, correct? Yeah. Okay, so minus V2. And as we come through, this would be what? I3 R4. Right, so minus I3 R4. And as we come up here now, we get to this R3. Ooh, what do you think? This is going to be plus, because we have the direction that we're traveling is against the direction we have picked I2 to go. Okay? So it would be plus I2 R3, and that's equal to 0. Okay? Because we are going, if we're saying that a voltage drop is when we go with the direction of current, if we're going against the direction of current, we're now, it's not a voltage drop, it'd be a voltage adage, I guess you could call it. Okay? So now you have all this information. And honestly, if you look at this, you have a lot more like I2s and I3s running around. So at some point, you probably would want to make the substitution and get your I1s out of there. Okay? At some point. But again, you wouldn't, in the test that you guys will be taking, you wouldn't see this and need to solve and get numbers. Okay? I'm going to guess that you probably just get the what is the application of Kirchoff's law number 1 and law number 2. What would that be? Right? So it's not that big a deal. Okay?